In this video, we're going to learn how to solve applied problems using the law of sines. In our first example, to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 900 meters apart. The first observation results in an angle of elevation of 47 degrees, and the second results in an angle of elevation of 35 degrees. Now, if the transit is 2 meters high, that's usually what you use to measure those angles of elevation. What is the height of the mountain? So what we're looking for is how tall this is. And for the sake of simplicity, we'll say that this distance the surveyor walks is on flat ground the entire time. So there's no change in elevation from these 2 points. So one has an angle of elevation of 47 degrees, so that's probably the one that's closer to the mountain, while the other one has an angle of elevation of 35 degrees, which is probably farther from the mountain. And then these 2 points are 900 meters apart and a direct line to the mountain. So I guess this is like the center of the mountain to like the center of the base along that line. So these are 900 meters apart. So now I want to find this height. And the best way I can think of finding it is I do have a right angle right here. So if I use sine of 35 degrees equals the height over the hypotenuse, which I'll call C for right now, I could find the height, but I need to know what C is. So it brings me to another triangle we have formed between the two sight lines. So if this is angle A over here, and I use this as angle C, and if this top part up here is angle B for this triangle with the dashed lines, then I could find angle C and angle B to hopefully find side C. So right here, 47, these are two supplemental angles along that line. So they're a linear pair. So what is the supplement of 47 degrees? C should equal this angle right here, 180 degrees minus 47 degrees, since we have a linear pair there. So that angle should equal 133 degrees. And now I have two angles of this triangle, so I can also find this upper angle, B, by subtracting these two angles from 180. So 35 degrees minus 133 degrees. B, this angle up here, would be equal to, I'm going to type this in just to be extra safe, 180 minus 35 minus 133 is equal to 12 degrees. So a very small angle up here. So now that I know this, I know the side opposite of B. So there's my pair of angle and side to use the law of sines. So now I know that if I use sine of B over B is equal to sine of C over C, I can find that side C. Because sine of B would be 12, so sine of 12 degrees over side B, which is 900, is equal to sine of C, which is 133 degrees, over side C, which is what I'm looking for to solve my problem. So again, I'm looking for that height, but I need to know side C to find it. So cross multiplying and solving for C, I'll get that C is equal to 900 times the sine of 133 degrees. Then after cross multiplying, you divide by sine of 12. You get C is equal to 900 sine of 133 degrees over sine of 12 degrees. So that makes C equal to, let's plug this in, 900 sine of 133 divided by sine of 12. And again, to be safe, I am in degree mode. That gives me 3,165.86. Now, this isn't the height of the mountain. This is that distance from the second results to the top. I'm looking for the height of the mountain. So now we go back to the equation I wrote earlier. And I'll see that sine of 35 degrees is equal to h over 3,165.86. And then multiply each side by that number, I get that h is equal to 3,165.86 sine of 35 degrees, giving me the height of the mountain as 1,815.86. And this is in meters, so it'll be 1,815.86 meters tall. It's a pretty tall mountain. Now let's look at another example on the right. Here we have Coast Guard Station Zulu is located 120 miles due west of Station X-Ray. So due west means that X-Ray is on the right, and due west means going to the left. Zulu will be on the left. And these are 120 miles apart. Now, an SOS call that is received, a ship at sea sends an SOS call that is received by each of the stations. The call to station Zulu indicates that the bearing of the ship from Zulu is north 40 degrees east, which means 40 degrees east of north. So if this is north, it rotates 40 degrees to the east of north. And for X-ray, the bearing would be 30 degrees west of north. So again, angles to the west of north. Now, how far is each station from the ship? So we want to figure out which station is closer to the ship that's sending out this SOS call. So we have a natural triangle that forms right here, but none of the angles on the inside to help us out. But luckily, since this is due west and these are north, these make a right angle right here between these two. So I can use the complement of 30 degrees, which is 60 degrees, to find that angle, and the complement of 40 degrees, which is 50 degrees, to find the other angle. And now I have two angles of a triangle, so finding the third angle up top, I'll call this point C from the ship. Angle C would be equal to 180 degrees minus 50 minus 60, giving me 70 degrees. And now I want to find out the distance from each station. And I have a pair of angle C and side C to use with the other two angles. So setting that up, I'll see that sine of 70 degrees over 120 miles is equal to, I'll start with station Zulu, sine of 50 degrees, and we'll call that B in the side A. B over B, that distance. So cross multiply, and we get B is equal to 120 sine of 50 degrees over sine of 70 degrees when I divide by it afterwards. So Zulu, station Zulu, would be how far from the ship? 120 sine of 50 degrees divided by sine of 70 degrees, 97.82 miles. for station Zulu. Ooh, I made a small mistake there. I should have used sine of 60, I'm realizing right here. So just to go back and fix that mistake. Realize I should use the opposite angle, not the one right next to it, to find that distance. So this angle down here is definitely going to change for Zulu. So I should use sine of 60 instead. That gives me 110.59 miles. So 110.59 miles for Zulu. And then now I'll do station X-ray, which I'll use the sine of 70 over 120 again, is equal to the sine of 50 degrees, opposite of that distance, over A. Solving for A, you'll get that is equal to 120 sine of 50 degrees, all over sine of 70, which was what I plugged in earlier on accident, the top one. So that's 97.83 miles, 97.82 miles. So X-ray would be 97.82 miles. So the station that's closer to the ship is station X-ray. But now if a helicopter is capable of flying 200 miles per hour, is dispatched from the nearest station, which would be station X-ray, how long will it take to reach the ship? So in order to solve this, I need to know that speed would be equal to distance over time. And solving this for time, I get that time it would take would equal the distance over the speed. That's why I'm cross multiplying and solving for time. So knowing all of this, the time it would take would be 97.82 miles divided by 200 miles per hour. So 97.82 divided by 200 give me 0.49 hours. Or if I convert that to minutes, multiply by 60, about 29 minutes to reach the ship. So usually, it's how we usually detect lots of locations, is we know a distance between 2 points, and we look at the bearings from those 2 points to calculate another distance. It's a very clever way to do this. And that is how you solve applied problems using the law of sines.